All right, well, good morning, everyone. We're going to go ahead and get started. Looks like we got most people coming on. So today's topic is how to stop custom code from killing your IIoT projects. 3 secrets to get your projects done in days instead of months. I'm Krista Duty. I'm the head of IoT Services Marketing for Telit, and I'll be your moderator today. Just a little housekeeping before we get started. If you think of any questions as we go along, please type them into the question pane of GoToWebinar. And we'll be having a Q&A session at the end of the presentation. For today's topic, we're going to be looking at connecting devices, how, it's really easier said than done, and we're going to take a look at why that is. We're going to look at how custom code puts shackles on your automation system, and how IIoT and scalability they're really at war with each other. And then we're going to show you how to get through these choke points, and you're going to learn today how to instantly connect your PLCs with your ERP application. You'll learn how to connect to your automation system without custom code. And you'll also learn how to set up edge devices so you can scale with less hardware and less software licenses. Today we have speaking with us is Jeff Smith, who's our VP of Business Development and Strategy for Industry 4.0, and also Terry Zanzuki, who's our software engineer for IoT Factory Solutions. And just a moment before we get into the meat of the content, I've got just an overview slide on Telit just to give you an overview of who we are and what we do. So Telit is an end-to-end IoT solutions provider. We offer everything you need, whether it's hardware modules to connect your things, connectivity data plans to connect those things anywhere in the world, and software platforms that empower you to bring everything together in one place. Along every point in your IoT journey, we offer our IoT know-how to consult you on any topic. So with over 15 years experience, we've really been at IoT since before IoT was a term, and we have a global footprint with customers from all over the world serving every industry. And a little bit about one of our IoT platforms is DeviceWise for Factory. It's a data-centric IoT software platform that lets you connect to your automation system with no programming. Jeff, next slide. Thank you. Okay, I'll start over. It's DeviceWise for Factory is a data-centric IIoT software platform that lets you connect to your automation system with no programming. It lets you integrate around your existing systems. You can build any IIoT solution with it. You can rapidly deploy anywhere and everywhere. And it scales to any size system, whether you want to start a pilot now or as large as you want to grow in the future. So with that, I'm going to turn it over to Jeff. He's going to get us going on our topic, and he's going to walk us through the 3 major choke points that are really holding back industrial IoT projects. So Jeff, over to you.
Good morning, Krista. Thank you, and good morning, everyone. So as Krista mentioned, DeviceWise is a Telit product that connects things to things. So if you look at the slide I'm showing now, it really connects on the left-hand side a multitude of plant floor devices. So in this case, I've got various PLCs, various torque tools, for example, smart sensors. The list goes on and on. It's literally hundreds and hundreds of various devices. And in the past, and even today, trying to connect those things to IT and enterprise level applications, be it a Microsoft SQL Server, something like SAP HANA, IBM DB2, it takes a little bit more than just connecting the endpoints. There's a lot of custom applications written out of there. There's a lot of custom protocol being used. And all of that leads to a significant amount of complexity. Even with OPC, and OPC is a very relevant and very predominant in the industry today, but it puts a certain burden on a control system that what we're trying to get away from, and what we've done with DeviceWise is eliminate that burden. In the top scenario, typically you've got a torque tool connected to a PLC. The PLC's got, talking to it over Ethernet IP or whatever the protocol might be or the network might be. And all of that data comes into the PLC. It's got to be manipulated with complex logic. It generally impacts the scan time of the PLC, takes up a certain amount of memory, and that's just the way we've always done it. I mean, I've been doing it that way myself for 20, 25 years. And then it has to get pushed to a PLC or pulled from the PLC into the PC, which causes a lot of latency and a lot of traffic on the network, loads up the PC significantly. With DeviceWise and with the methodologies we're going to talk about today, the torque tool doesn't actually send data to the PLC. There's still a control loop in place, but generally when you need data from the torque tool, it sends it directly to DeviceWise on event. So only when the data is needed. So there's not a lot of polling going on. In fact, there's very, very little to no polling going on from the PC to the torque tool. The same thing can be true with the PLC. Instead of having to poll a PLC and try to get data out of it cyclically, the PLC can send data on event to DeviceWise. So it does what it does best, which is control systems, and it partners with DeviceWise in sending on-event data only when that data is relevant or necessary. You know, in the past, and I've written a lot of custom applications myself over the last few years before I was introduced to DeviceWise, and there's, you know, the various protocols that you have to deal with, the various packages, the programming environments, they all add risk, they add management. You know, the initial development is one thing, but it's who owns that programming. You know, if you've got really smart guy on the plant floor, Joe, and Joe leaves the company, and Joe was the guy who was writing all of your custom code, now you have a problem. So there's an inherent risk in that. Not only that, you have to constantly update and maintain that code, so it's an ongoing effort. Whereas using an off-the-shelf package, that effort is taken care of by somebody else. One of the other choke points, Krista mentioned it earlier, is scalability. You know, it's very easy to put a small system in today, connect to a few devices on a plant floor, and then connect them back to a PC running something, for example, an OPC server or a custom. I've seen people that run a lot of custom Python scripts that execute on a interval of 1 minute or 30 seconds. The problem with that is as you try to scale that up, and in the world of IIoT, we're not talking about 5 or 10 or 20 devices. We can be talking about hundreds and thousands. It gets very, very difficult to scale that. To get the scale or the economy of scale you're looking for, typically you have to slow down your ability to collect data or interface with those devices. In the case of DeviceWise, we have single instances of DeviceWise that talk to hundreds and thousands of devices. It simply scales well, and it's very fast and robust, so it allows that level of control and that level of interoperability with different systems. You know, in the typical model today, one of the pain points is all of the licenses that you have to manage. So you've got to manage complex licensing. You've got it distributed all over the facility or perhaps all over the enterprise. You've got the total cost of ownership. So you've got the initial investment, you've got the deployment, and then you've got the cost of ownership, which includes training, it includes maintenance, it includes things like PC life cycles. What about virus, antivirus? So there's just a whole pile of things that go into maintaining the more and more computers and devices that you have to service your need in terms of connectivity. So secret number one, if you will, use a data-centric IoT software package to map devices to applications. So the long and the short of it is collapsing all the middleware, be it custom or somebody else's middleware, where you have multiple layers of servers and clients, down into a single interface that allows you to talk natively to devices on the plant floor side or on the manufacturing side or on the industrial side, and talk directly to the enterprise or even the cloud with little or next to no programming at all. So with DeviceWise, for factory, we can talk to those native devices via their native protocol. So in the case of Rockwell, for example, Ethernet IP, Siemens, their industrial internets, you know, all of the various flavors that are out there, there's very little that DeviceWise doesn't talk to in a native way. And on the enterprise side, which is typically the northbound side, but not always, because data can move in omnidirections. It doesn't have to necessarily be from the plant floor just to the enterprise. On the enterprise side, you've got native connections to just about everything you can think of in terms of enterprise systems. So the beauty of that is there's a lot less layers, a lot less connection points necessary and choke points in terms of scaled architecture and hardware, and it's a much more streamlined system. So you can take something as simple as putting PLC data directly into a SQL database, an Oracle database, a Mongo NoSQL database, SAP HANA, SAP, various flavors, IBM DB2. The list goes on and on. You can talk directly to SCADA systems. So you can take PLC data or sensor data from a multitude of PLCs and sensors, torque tools, and you can talk directly into SCADA systems. More importantly, you can have applications talk to other applications. So in conjunction with talking to edge devices on the plant floor, you can talk to ERP systems, you can talk to SCADA systems, and those systems can communicate with each other. So for example, a PLC could enter a ticket in Maximo, which is a work tracking system, and then Maximo can push data over into the another database or another system on site to indicate that the ticket was solved or correctly closed out. This slide, it really talks about, on the left is a number of the industrial devices that are probably commonly known. So smart devices as far as these PLC families, standards-based protocols. We talked multiple protocols, all sorts of devices. I mean, literally the list goes on. It's hundreds and hundreds of devices. And on the right side of this is some of those enterprise applications I was just talking about. So I'm not going to spend too much time going over what those are. You can see that list, and there's actually significantly more than what's shown there. And the beauty of DeviceWise is that it integrates into your existing architecture. So if you have an architecture in place because you've got some legacy or brownfield plants or environments, DeviceWise will fit into that architecture and work with the infrastructure that you have in place. It doesn't require you to change everything you have to use it. Now that being said, sometimes there may be ways to improve upon it with newer developments, and DeviceWise is flexible enough to do that as well. When you have DeviceWise in place, it's got built-in cloud connectivity. So what that means, and in my former life of managing a large tier 1, when I deployed DeviceWise to the plant floor and we started connecting plant floor to the top floor or the enterprise systems, if executive management came along and said, we've got to get us some of that Industry 4.0, we need that. I'm not sure what it is, but I think we should be doing it. And when that happens, your answer is either, we got you covered, the system we have in place today is capable, we just have to figure out what we want to do, Telit can help us with that, and then we just have to turn it on and start using it. Or the answer is, yeah, we're going to have to look into that, haven't really given it any thought, don't have anything in-house that can do it, we'll probably have to buy something. I'm pretty certain we all agree the first answer is the one we want to give. So that's the beauty of DeviceWise. If it's there, you can connect to the cloud, the enterprise, simply by choosing to do so. There are APIs available for customer unique enterprise solutions. We have some customers who like to develop their own front ends. That's fully available. We have customers who like to develop their own driver interfaces to very specialty pieces of equipment. We have an SDK that's available, so it's very easy to connect to that one-off piece of equipment that's been out there forever. And Telit also offers services from the perspective of developing those drivers. So if you have a very odd piece of equipment that you'd like to talk to, we can probably talk to it or develop a driver to do that with you. Unsolicited communication, talked about it on some of the earlier slides. A great way to get data based on event versus polling. And of course, DeviceWise is fully compliant with OPC, DA, and UA for those instances where that has to be the way to do it, or it simply makes sense. So decisions at the edge. The nice thing about DeviceWise is you don't, I should say one of the many nice things of DeviceWise is you don't need to know those custom programming languages. The one guy who knows how to do this stuff. DeviceWise collects data and either just moves it as is, or it can make decisions upon that data, aggregate the data, manipulate the data. I mean, there's no end to the possibilities, and it does it with a very simple flowcharting language. So if you can create a flowchart, you can use DeviceWise. Makes it very, very easy to train multiple folks on staff, and the online help in the wiki system alone is phenomenal. So it makes it very easy to come up to speed with how to do things. The other thing it does is it does a common enumeration of different PLC tag types. So what that means is when you connect to a Logix PLC, you don't need to type in tags. It goes out and enumerates all of the tags in that PLC. The same thing is true with Siemens, Mitsubishi, and you can even go so far as to create aliasing for the tag types and the devices so that every tag from every PLC as far as device-wise is concerned looks exactly the same. So you can build very modular, very repeatable flowcharts that doesn't really matter whose PLC or device you're talking to. It'll simply work. So with device-wise, the software is multi-pooled, multi-threaded. It runs on multiple operating systems. I think when we do a build, it builds for 32 different operating systems at the same time. So whether it's Linux, whether it's Windows, whether it's embedded, whether it's if you want to run it on a Raspberry Pi running Raspbian Linux, if you want to run it on IBM's AIX, the HPOS, I mean the list goes on. So we have customers that run it on the plant floor, Windows and Linux, up in the server rooms. It really allows you to reach out and touch multiple devices with a single layer or a single interface. It doesn't require you to have multiple layers of PCs, software licensing, and connections. You simply, you can get to 800 devices and you're still not taxing the system. It's very robust and it's very thorough. We have many customers doing that today. Okay, so at this point I wanted to take a minute and kind of create an interface in DeviceWise. We're going to talk to, I have a Logix, Control Logix PLC. I've got a SQL Server database sitting here. And I'm going to create an interface to that to simply collect a little data from that PLC. Within the PLC code, it's just randomly generating some pseudo production data. A couple of torque tools, couple of presses, part number, serial number, that type of thing. And it's going to insert that data into a SQL database. My goal is not to show you everything we can do, but simply how easy it is to do one of the most common tasks that people try to do, and how little, when we say it doesn't require custom programming, what we mean by that. So let me get that started. Let's quickly take a look at the PLC for a minute. And I don't want to go too quickly depending on connections. Krista, are you able to see the screen?
Yes, I can, Jeff. You're doing good.
Okay, thank you. All right, so this is an example of a single Boolean tag, and we're going to use this bit to trigger a transaction. And then we're also going to do something called an unsolicited transaction if we have time, and Krista doesn't tell me I'm being too long-winded. And we're going to take some of this controller data that's sitting here in the PLC, and as you can see, it's just randomly changing. And we're going to move that to a SQL database. The SQL database is over here. And if I execute it, we can see that the database is currently empty. All right. To do what we want to do, we're going to fire up what's called the DeviceWise workbench. DeviceWise really has two pieces. It has what we call the engine, or the transaction engine, and the core. And that's the part that does the heavy lifting. That's the part that does the work. Now to interface to that, we have a tool called the workbench. The workbench does not need to exist on the same system or PC. It can run on your laptop, and you can run the core or the engine on a server. You can run it on an IPC on the plant floor. And the beauty of it is you can manage all of those instances from the workbench. Now I will add a caveat. We're not going to talk a lot about the security side of it today. But DeviceWise has very granular security. You can create users, policies, roles, and really determine who can do what down to the tag level in a PLC, for example, if a person can only see it. So you have a lot of control in that regard. So looking at the screen, I've got my laptop here running at 172.21.035. And if I right-click on nodes and I scan, and I select network, I'm going to have it scan this network here. It's capable of scanning whatever's connected to the PC you're running it on. Okay. And I thought I had my other laptop running, but apparently I don't. Normally it would list them all right here. In this case, you can see that it's showing you the same laptop on multiple NICs. If you had multiple instances of DeviceWise in your environment, they would all show up in this list here. So let me just get rid of one of these just so things are a little more organized, and we're just looking at the one. And I'm going to open up the node managing or connected to. There's an administration is where you handle things like licensing, configuration, and the one thing I want to talk about there are packages. So DeviceWise is very scalable. It allows you to add more packages which increase its ability to talk to and interface with different things. So I have a handful of them installed here. Some of them are single drivers like SNMP. I can use DeviceWise to actually manage switches. From a managed perspective, I should say monitor. I can look at the switches, the throughput using switch MIBs, and actually keep track of the health of the switches on my network with DeviceWise. I've also got the industrial driver pack, which includes the PLC connectors for, Rockwell PLCs, Siemens PLCs, Mitsubishi PLCs, Omron PLCs, Schneider PLCs, and the list goes on with what we can connect to from within that single driver pack. And then there are a few other things here that we're not going to talk to in the context of this demo. And I would like to say, when we're done and there's question and answer, and there'll be follow-up that Krista will handle. But if someone wants to take a deeper dive into DeviceWise, we can certainly schedule that for a later date. So today, we're giving you kind of a cursory look. All right, so let's talk about devices. If it's DeviceWise, the first place to look is the devices option. So if I'm going to add a device, I am going to right-click on it, say New, give it a name. I will call it PLC Control Logics. I'm going to drop down my list, and this list is populated based on the packages that I have installed. And I'm going to say Control Logics. I happen to know it's at 192.168.200.12, and it's in slot 0. I'm going to open up Advanced Properties, because by default it enumerates program tags. I don't care about aliases, and I'm going to create the UDT binary description file. What that means is DeviceWise will pull all of the data types, UDTs, out of the PLC and create a representation of them that I can use in DeviceWise without having to enter tags or data types by hand. I've got the device definition validated, which tells me that DeviceWise saw the PLC, it's where it is, it's where I said it was, it's what I said it was. And now if I click OK and save it, and I start that device, and I go to my variables list, you can see that DeviceWise has gone out and auto-enumerated that entire PLC. So here's that data we were talking about that you saw running in the PLC. I can either just select it and say read it, if I just want to see what it is today at the moment, or I can actually right-click it and say watch, and I get a live watch list that I can save that shows me the data changing inside the PLC. Okay? All right. So from there, we're going to close this because I don't need it for what we're doing. And we're going to go over to the Enterprise tab. Now, Enterprise is, think of it this way. Devices are all the edge devices, all of the things out on the plant floor or in the industrial environment that you might want to connect to, the sensors, the things of the manufacturing world. The Enterprise side is when I want to talk to all of the things on the Enterprise side, such as databases, messaging queues, Maximos of the world, SOAP, web services, anything really that you would talk to on that side, or the cloud, and if you talk directly to the cloud with DeviceWise as well. So to talk to something with DeviceWise, you create something called a transport, and in here I already have one. It's called SQL Server, and the SQL Server is 192.168.62.122. Now I might need to change this because I don't know if I can see that from within this VM because my SQL Server is in the host operating system. So we're going to try that. We're going to go look at administration, and we're going to go look at what IP addresses we have. So 192.168.200.14. So we're going to go here. We're going to edit this. That's my database name, 192.168.200.3 is where the other PLC or my host operating system is. And my password, and with any luck, I can see it from in here, and I can. So if I click Transport Definition Validated, just like on that device, this tells me that it's where I think it is, and DeviceWise can see it, talk to it, and work with it. Now, I'm not going to spend a lot of time going over the options within this dialog, but one of them that's kind of interesting is Store and Forward. Store and Forward allows me to tell DeviceWise, if you can't reach the enterprise device, start queuing up the transactions. And this works across a multitude of different enterprise devices. This gives me the ability to not worry about fuzzy wireless or flaky wireless or somebody rebooting a IDF or a BDF or somebody restarting a server with a database on it, because DeviceWise is going to queue those transactions up and it's going to feed them in the order they came in. And you have a lot of flexibility with how that works. So I'm going to save this. And the next thing to talk about is a transport map. Now in this case, I have two transport maps already defined. I'm going to get rid of one of them so we can simply create it again. And it's telling me I have projects in here. Oh yes, stop. This is the downside of having already had stuff in here instead of the clean one that we were starting with. So transport maps, let me get rid of those. A transport is what I want to talk to a database. A transport map is how I want to talk to it. How do I want to talk to that device? Or excuse me, that enterprise system. So in this case, we're going to do a very simple transport map. We're going to call it transport map SQL. Transport is going to be a type database. It could be different, but we're going to call it its database, and it's our SQL server. Now one of the things you'll notice is as soon as you select the database and the transport, it goes out here on the to enterprise and it finds the database you've chosen. And that database was defined in our transport, DWDB. And within that database, there are a number of tables. The table we're looking for is Logix PLC process data. The action is insert. Now there's a significant number of things you can do down. You can do stored procedures, you can do inserts, deletes, you can do the wheres and order bys, and again, all of that's beyond what we want to talk about today, but it's extremely powerful and extremely flexible. So if I open this and look, you're going to see these are the columns in my database. If I go back to my database, there's those columns right there. Right? Same columns that we're working with in here. Now, I need to figure out how to get data from my PLC or system. I need to create a pipe with this transport map, basically, that says from my trigger, and trigger is where we do things, events, how do I get data to these columns? So I could literally go and create a tag here, or a pipe column here, if you will, and tie it into this, or I can use the easy button and let DeviceWise do it for me. So you'll notice that it's created column PLC from trigger, column source, column serial number, and it's mapped each one of those to a specific column in my database. And that's all I need to do. So if I hit validate on this, it's going to show me the query that it would execute. And I'll save it. So now I've created a transport map, and I've created a transport map. And now I can go to projects, and I can create a project, and I'm going to call it My Data Project, and I'm going to start it. I'm going to open that up, and now I'm going to create what we call a trigger. And the Canvas editor allows me to do it graphically with the flowchart. That's what I prefer to do. So we're going to open this thing up. And a couple of things about triggers that will help as we're talking is the trigger has events, local variables, static variables, and some various settings. The event is what kind of trigger are you going to do? Well, in my case, we're going to do just a very simple trigger. We're going to call it a data trigger. and I'm going to browse to the tag that I want to look at in the PLC. And if I go look at this PLC and I open up the program My Station, I scroll down, I see a tag called PB Trigger Write PLC, and it's a Boolean. That's the tag I want to use to trigger this transaction. And I'm going to set a little bit quicker priority, and I'm going to do it when the tag, or the Boolean, equals 1. So that essentially means it's a 0 to 1 transition. Now, we also have local variables, which are variables I can use in the trigger. They exist only so long as the trigger is executing. So they're created at the beginning of the trigger execution. They're destroyed at the end. Static variables are created when I actually start the trigger, which you'll see me do in a moment, and they stay. So they persist for execution to execution of the trigger. All right. So now, to move data to a database, I've got my start. I need to go to Enterprise Communication. I'm going to grab a transaction, drop it in there. Every good flowchart has to have an end. So I'm going to end my flowchart. And then I want to do some error handling, but just very basic. So I'm going to grab this catch-all error handler from here, drop it in, grab the end execution in red, which means that something ended incorrectly or badly, whereas green obviously means something was successful. And that means if for any reason any block, any action of this type, and there are just all sorts of them over here, things you can do, errors out, it will go to here. Now the other thing this is, because this is a transaction to the database, it's got to be able to tell me if that connection goes into store and forward, meaning the database, for example, is unavailable. So the transaction was queued. So DeviceWise gives you an option this way out of the transaction action block to do that. For purposes of example, I'm going to send it down here. I could go this way, send an email, send an SMS, log something, do all sorts of things that allow a person to take action if this were to occur. So that gives me my basic flowchart setup, and then I just have one more thing to do. If I open this transaction block, and I open this up, you're going to see, remember that column PLC when I created them in that transport map? It selected that transport map because it's the only one I have, and it auto-populates each of these columns. So for me to get data into that table, I'm going to go pick some tags from the PLC. So my control logics, my data to store PLC. Now, because I can do this from multiple places, the other thing I wanted to show you is DeviceWise has some built-in things to do, things you can work with. So a macro, for example. If I want to store in the database that this particular transaction came from a specific trigger, I can say macros trigger, and it's going to take the name of this trigger, which we'll give it in a moment, and it's going to stuff that in the database. So let's go back to our PLC here and look at our data again, and I need the serial number, part number, the cut press force, and distance, seal press force, seal press distance, and I've only got 4 more here. Drain plug torque, drain plug angle, fill plug torque, and fill plug angle. So I've basically told DeviceWise, when this transaction is triggered, take the contents of all of these tags, pipe them through this transport map into the database. Now, I don't think I can get to the internet from my virtual machine here since we've kind of changed up what we're doing, but the really great thing about DeviceWise, again, one of the many greats, is when I run into trouble with something, I can click this help button, and I am connected to the internet from in here. Great. And it takes you to our wiki, which is bar none the best I've ever worked with. I mean, I was using this when I was a customer of Tellit's, and it gives you context-sensitive help, whatever you're on, wherever you're at, and gives you great detail on how to do what it is you want to do. So it's a phenomenally powerful tool. So I've created this. Now the last thing I need to do is go to this output tag, and when I do a transaction with the database, typically you're going to get back a result and some other values. So I'm going to go ahead and create 3 local variables just to populate this field. So I'm going to come up here, I'll get this out of the way, and I'm going to say add, and I'm going to just call it status, and it's an int4, I'm going to add count, which is also an int4. Notice it kept the same name, or the same data type. And then I'm going to add key, which happens to be an int8. Int4, by the way, in the Rockwell world is the same thing as a dint. So there, I've created those. I just need to map them to my fields. And we're done. So if I close this and I validate, trigger name must be filled in. Okay, so I forgot to fill in a trigger name. So I'm going to come up here and call this my bool trigger, because I'm just that creative. And I'll validate again. And DeviceWise is telling me everything's good. What you've got in the transaction is good. What you've got down here on this canvas is good. Life is good. So I will save it. Close it. Oh, I want to do one more thing. Turn on reporting. So every time DeviceWise executes this trigger, it'll give me a report of what happened. Normally you would set that to these fields for max timer on error once you get it working the way you want it to. For now, I'm going to say just always on. And if I close that, you remember I mentioned with the static variables once I start the trigger. So as soon as I click start, those static variables, anything I might have defined, in this case I haven't, are created and they will stay running. So now, assuming everything is working the way we want it to work, if I jump over to the PLC and I go find that bit we were talking about, which happens to be in here, and I toggle it, and then I go look at DeviceWise, I should see that the trigger executed once. It did. I should be able to go to my reports and see that it executed once, and it did. And I get a detailed breakdown of what happened. And in this case, anytime you do the first connection to a database, it takes a little bit longer. So if I were to jump over here and do this one more time and come back, I should see another report, and you'll notice it's now 5 milliseconds. So it took me 5 milliseconds when I saw the trigger bit go high in the PLC to get the data, execute the transaction, and report that I was done. And the transaction took 2 milliseconds. And I can actually walk right through every piece of what occurred within that transaction. So the proof in the pudding, however, will be if we go to the database, I do a query, I should see 2 entries, which I do. My bool trigger is where they came from. They pulled all the data out of the PLC, out of those random generations I had going on. So I literally just inserted data into a database with a single action block and a flow chart, pulled all the data out, transacted to the database, and replied with done. And it took a grand total of, oops, wrong one. Let me just get rid of you. It took a grand total of 5 milliseconds round trip. So that was beginning to end. There's a lot of other options we have, and I have a example set up for you to do unsolicited. I don't know how we're doing on time, Krista, with our slight detour.
We probably spend another 3 minutes, Jeff. You can go into some unsolicited stuff, and then we can hop into the Q&A. We got some questions coming in.
Okay. Let me first move the stuff. I was going to show you another great feature of DeviceWise, and that is the ability to import and export. So when you create something, it's very easy to export it from DeviceWise, you know, make a quick change to it and then import it. So you can literally duplicate things over and over and over. So I need to go into my desktop where I was storing all of that stuff that I was going to show you and get it. So I need to grab this, and I need to copy it to my desktop within my VM now. And what I can do is I can go up here to Projects and right-click. I can say Import, pick what I've exported earlier. This is an unsolicited trigger. And it's telling me I'm going to create this device, or this trigger. I'm going to add a device called PLC Unsolicited Listener. I'm going to reference UDT or a data type from that PLC called DB process. And I'm going to look at a transport map SQL, and I'm going to create a transport map. So when I import that, it's done. If I go into my data project, I should see a second trigger. And it's a Rockwell SIP, because it's simply going to wait for a SIP message. Now if I go down to my devices, I will see that I've imported an unsolicited listener. Let me open it up. The default Ethernet IP port is 44.8.18. Now that I've had to change this demo up and do it from within this Rockwell VM, that'll be a problem for me because RS Links Enterprise owns that port. If I change this to 44.8.19 here and save it and start it, now I've got a listener. I can go to my trigger, I'll start that. And if I open it up, you're going to see that the event is a little different. The event in this case is called a Rockwell SIP. I picked my unsolicited listener device, and I basically defined the command and these various pieces of data that come from the PLC. So the easy way to look at that is to go here, go to here, and you can see a message instruction. And if I edit that message instruction, I'm going to see that I've basically created a message instruction that sets attribute single, and I picked these numbers. They're absolutely arbitrary and random. I picked the size of the data type that I want to send. So this is that data to store that we browsed each tag of and added in the last one. And communications wise, I'm going to go to 2.192.168.200.3. Okay. But that's not actually where this device wise is. That's where the other one was. This one is going to be at 192.168.200.14 because I'm running from within the VM. So over here, I need to change this to 14. And if you'll remember, I also had to change the port that it was on because RS Links likes to own the default Ethernet IP port. So this is 44.8.19. And I can apply it. So this tells Logix to send it on a different port than the default. I haven't done this from inside the VM, so hopefully it works the way I'm expecting it to work. And I go back to my triggers. Let me make sure that this is turned out. You might get to see me do a little troubleshooting. Oh, and let me also make sure that I may need to make sure that my firewall is turned off because I don't think I have it set up to let things out of my VM like that. We'll try it, right? I'm going to open this trigger back up. You'll remember, those are those numbers, 1044, 99, 55 in the message instruction. It was 104 bytes. And then in the actual trigger itself, you're going to see that we grab the data. We use that UDT that we exported from the PLC to format it. We're going to output all of the same values into a local variables that we've created. And again, I set this up last night. There's my transaction map. Looks very similar. I'm passing in local variables now instead of the ones directly from the PLC. And then I send a result status back to the PLC saying life is good. So if I validate it, it's good, save it, close it, and let's see if it will work on the fly. Okay, so what this tells me is it's not getting out. Because normally what will happen, and what's nice about this, I actually lost a bet on this one time. My argument was that when the message block happens, the done bit's going to, oh, it did get out, good. My argument was when the done bit comes on, it just means it handed the message off to the Logix COM process, and the done didn't mean it actually got there. Well, I was proven incorrect by a good friend of mine. And it actually will require the ACK to come back from device-wise or you won't get it done. So all of that complex handshaking I've been using over the years goes away, and I get to use TCP and the inherent handshaking in the protocol to get it done, because device-wise won't give me a done bit. I won't get a done bit on this until the data gets there and device-wise responds back to the message. So it's actually pretty nice. So if I come back here and I go look at my reports, oh, there it is, my unsolicited trigger. And it took a little bit of time, right? And I think part of that was getting out. Part of it has to do with this VM. Let's see if it gets any quicker the second time. Much faster. So if I do it this time, it took a millisecond. Oops, took 1 millisecond. So that's a little quicker. So 1 millisecond to do the transaction. If I go to my database, let's see, I made this thing full screen somehow. Let's go to my database. Let's go to my database, execute the query, and I didn't get there. So I wonder if I have this database inside that VM as well. Let me see. I do have one running in here, but I don't have the management console. Because if I look and see, the transaction actually worked. Everything went where it was supposed to, but I can't get there to show the data to you from the unsolicited simply because I don't have the management console. Process data columns. Yeah, it should be here. It may have also stored and forwarded, but that gives you an idea what the unsolicited looks like. It gives you the ability to send data on demand. So now the PLC decides when the data is going, right? So instead of polling for the trigger bit as we did here, which being able to do that is great because it allows you to meet existing legacy applications. In my former life, we literally replaced multiple levels of middleware with this application, and because of the logic engine and the ability to do this, neither the PLC side or the database side knew that we'd replaced everything in the middle, and we picked up significant performance and robustness. On newer systems, we designed it to use an unsolicited methodology so that we could take advantage of lower throughput on the network, or excuse me, lower latencies in the network, lower network traffic, and the PLCs only send it when it's necessary. So device-wise can support many, many hundreds of devices, thousands of devices, because it's not sitting there trying to pull every device. So that's what I had for today. I apologize for the bump in the road. Windows being what it is, for some reason my host decided not to communicate with anything. But I think you saw that I was able to quickly install and bring it up and running in the VM and get it talking to the PLC, and everything worked pretty much as I expected it would at that point. So Krista, with that, I'll hand it back to you.
All right. Thank you so much, Jeff. You brought up a lot of really interesting points and showed how easy it is to get factory IIoT ready. Go ahead and jump on over to the slides, Jeff. Okay, here we go. Before we get into our Q&A session, I just want to take a moment to mention Tellit IoT University. It offers 2 days of 2-day classes that will quickly give you a good idea of the capabilities DeviceWise has to offer. People always walk away with telling us how blown away they are by the products and how they have so many ideas that they can take back to their jobs. So it's really a dynamic place to come, learn about IoT, learn about DeviceWise, and have a good time doing it. So we're going to head into our Q&A. Bounce into the Q&A slide, Jeff. So we got a few questions I want to try and get through. If we don't get to your question, we will definitely follow up with you after the webinar. So the first one we've got is, how do we talk to old unconnectable devices? An example given is like a CNC machine. Jeff or Terry? Before you answer that, just so I can say what's on the slide, if you guys want to have a demo, have more one-on-one time to get into like some more deeper questions, talk about your unique system setup and how DeviceWise can work, please raise your hand in the GoToWebinar slide, or the pane that's over there on the GoToWebinar section, or you can call us directly at the number on the screen. Okay, Jeff, so just again, how do we talk to old unconnectable devices, something like a CNC machine?
Okay, great. And that's a great question. And the other thing they can do too, Chris, is we can send them a 60-day license, and they can download the software and have full functionality and play with it to their heart's content. So just by raising your hand or that phone call, we can do that as well.
Awesome.
From a CNC perspective, there's a lot of CNCs out there, and there's a lot of injection mold equipment. There's a lot of machines that have been around forever, and in today's environment, people tend to reuse assets. I mean, that's just the name of the game. But at the same time, they want to get data and they want to understand what their efficiencies are. They want to know where they're losing time and money using these older machines. So it's kind of a paradox in that regard. With DeviceWise, we've created a product called an Atom 16, or with Telit. It's a digital to analog, or a digital and analog to Ethernet conversion, if you will. It's pretty low cost for all the functionality you get, and it will take digital signals from CNCs and old equipment. We can parallel off of stack lights for the green, for in cycles, and analog values, and it sends it to DeviceWise, and then the DeviceWise side, you can do some math, do some simple calculations for efficiencies. You can monitor downtimes and uptimes. We have hundreds and hundreds of them in the field. We have customers who have been able to shut down third shifts, reallocate equipment because of the efficiencies and what they've learned by tying DeviceWise into these older machines. I mean, I used to try to figure out how to talk to all these older machines, and the problem was that there might be 6 NICs in existence for that machine. They're $10,000 a piece, and they're 10 megabit half duplex. So it really wasn't an option. So this Atom 16 option gives us the ability to connect to all of that old equipment and get meaningful and actionable information, and we've got customers doing that today.
Thanks, Jeff. I'm going to take one more question because we are at time. One of the questions is, can we manage our controls network with DeviceWise?
Well, manage is kind of a big word. There's a lot of implications of when you say manage. There are certainly aspects of your controls network that can be managed with DeviceWise. Yes, can you look at and monitor switches and the connectivity between switches, and are certain ports in half duplex and certain ports? Yes, absolutely. Can you look to see and can you be notified if devices fall off the network? Absolutely. You can monitor the status of PLCs and things that you have connected and see when they go offline, when they come online. So there's a lot of capability in there to do that. Currently, I don't believe that we can back up assets from PLCs, for example, with it, but I know that's something that's on the roadmap, and it may not be too far down the road.
All right. Thanks, Jeff. Well, thank you, everyone, for attending the webinar today. Thank you, Jeff and Terry, for being on the line and presenting some great material. With that, the webinar is concluded.